everybody. This is Dr. Collins. Today we are going to be talking about independent samples t-tests. So this is the first video about t-tests. We're going to have two because we're also going to talk about dependent t-tests, but that'll be in the next video. So I hope you're all doing well. Please, make sure to reach out. Let me know if you need anything. If anything is wrong, if you need help with anything, I'm more than willing to listen. Let's all be thankful that we are mostly seem to be happy and healthy, or at least healthy, if not so happy. So, and thank you all, please. Thank you all as well for being so gracious during this time, being accepting of the videos that I've been posting, because I know they're not perfect. So if you have any questions, of course, reach out to me, let me know. Okay. So of course you can see there the theme sort of related to this topic is going to be trans rights, and really just attitudes towards transgender people. That's going to be our running example throughout. So figured I'd include, the trans rights rally that's on there, as well as the colors from the trans flag as our color theme throughout these slides. Okay. So let's talk about our agenda. All right. Well, we're going to start by talking about an example, right? The transgender rights example, okay? Then we're going to talk about what test we should select, right? So we're going to walk through all those steps laid out in your textbook for statistical testing, and then we're going to talk about how we interpret those results. And very briefly at the end, I'm going to touch on why we used independent as opposed to dependent samples t-test, okay? And here, of course, you can see this is the cover of a book, which was co-authored, of course, by our very own Dr. Lewis, okay? So you can see there that Dr. Lewis is the co-author of this book along with his colleagues from a variety of schools. He's been doing this project for a long time, looking into transgender rights and public opinion on transgender rights. So this is sort of his area of expertise, and so I cite him a couple of times. All right, so moving on. Our example. Now, prior work has shown that education may be related to openness to trans rights. However, that evidence is somewhat mixed, right? In fact, in one of their projects, Dr. Lewis and his co-authors found that in 1 out of 3 surveys, there was no significant relationship between education and attitudes on trans rights, but in 2 others, there was in fact a relationship between education and trans rights attitudes. Okay, so the evidence is somewhat mixed, right? You have access to the 2016 ANES, which asks a lot of feeling thermometers, including a feeling thermometer about trans rights, about transgender people, rather. Okay, and you also have data about education. So you're curious, right? To what extent is education related in the 2016 ANES, the best survey data that we have? Okay, so you go ahead and take a look. All right, so that's our running example. Now, statistical testing steps. Right? Remember, step one is that we define our null hypothesis. From there, we set our level of significance that we're interested in. And again, just a pro tip here, just set 0.05, two-tailed test. That's it. Okay, that's all we're going to use from here on out. And then we're going to select our appropriate test statistic. Then we're going to calculate that test statistic. Then we're going to consult a t-table to determine the critical value we need for our significance level. Then we'll compare those 2 results and base our judgment on whether or not our test statistic is greater than or less than the critical value. Okay, so just a reminder of those 8 steps. It's really 7 steps, right? If you reject the null, then it's 1, 2, 3, 4, 5, 6, 7. If you don't, it's 1, 2, 3, 4, 5, 6, 8. So steps 1 and 2. Well, let's say we think there's a difference between those with and without a college degree, right? Here defined as bachelor's degrees, not associates. We have our research or alternative hypothesis, okay? And that is that the mean trans feeling thermometer for those with a college degree and those without a college degree will be different, okay? They are not equal to one another. So, of course, the corresponding null is, in fact, that the difference between them is 0, that they are equal. Okay, so that's our null hypothesis. From there, we also determine our preferred significance level. And again, our standard choice should almost always be a two-tailed p-value of 0.05 or less. There may be times we want to use a one-tailed test. For instance, if we think that one mean will be higher than the other, and in this case, we probably do think that those with a college degree will have better attitudes towards transgender people, right? In that case, we have a directional hypothesis. We can use a one-tailed test. But really, it's just best practice in political science. We always use two-tailed. So choosing the right test statistic. Let's walk through what we've looked at before. We have a ratio level dependent variable, trans feeling thermometer, and we know it's ratio because 0 means absence of warmth here, right? You can't go negative, you can't go above 100. 0 actually means total absence of warmth towards that group. It's like absolute 0. Okay. We have a nominal independent variable. It's really a dummy variable, right? Those with and without a college degree, so a 0 or 1. So which test should we use? Well, obviously we're going to use an independent samples t-test, but let's talk about why. Well, if you recall, this little flow chart is the one I came up with, right? So how many independent variables do we have? Well, of course, we have one independent variable, okay? Now, with that independent variable, it's nominal, so we're going to use either a t-test or a dummy variable regression. And in this case, we're going to use a t-test for independent samples, okay? So why do we use the independent samples t-test instead of the dependent samples t-test? Well, let's look back at that flow chart from your textbook, which in this case is actually somewhat useful. Okay, so here's that flow chart. Take a look at this. All right, the question is, we want to examine differences between groups of one or more variables. Are the participants being tested more than once? In this case, no, right? It's simply two different groups, right? We're dealing with two different groups. They're not being tested multiple times on this question. All right, so the key is that it is different groups. No one in the first group, those with college degrees, is also in the second group, those without. They're mutually exclusive groups, okay? If it were the same group, tested on the same question at two different points in time, we would use a dependent samples t-test. And in fact, that's what we're going to do in our next example after this video. Now, sometimes we call a t-test the difference of means test. All right. In fact, that's very often what I've gotten used to calling it based on how I was trained, but it's also often called a t-test. The problem is that you have one sample t-test, you have two sample t-tests, you have multiple samples t-tests, right? So I'm used to just calling it a difference of means test, right? Whatever you pick, it's fine. Your mileage may vary. So now we calculate that test statistic. In order to calculate it, let's work with some data. All right. So I went into the ANES and I pulled out those with and without college degrees, and I looked at their mean transgender feeling thermometer. So those without bachelor's degrees have a mean transgender feeling thermometer of 52.57. There are 2,429 people in the sample who fit that category of not having a college degree and who answered this question. Standard deviation is about 28, and the standard error of the mean, which we could calculate ourselves, is 0.573. Remember, the standard error of the mean is always just the standard deviation divided by the square root of the sample size. We don't have the population standard deviation. Okay, so that's our standard error of the mean. If you did that math, it would work out to 0.573. Compare that group with the alternative group, right? Those with a college degree or higher. Their mean transgender feeling thermometer is quite a bit higher, 60.15. All right. Fewer people in that category, 1,142, which makes sense. A majority of the public still does not have a college degree. Similar standard deviation, standard error of the mean is greater. Okay, and of course it's greater because we have a smaller n. So you're dividing by a smaller number. Okay, so to calculate our t-score, here is our method. Now your textbook looks a little bit different. I'll get into that in a moment. Right, but the basic is, just like in a one sample t-test, right, we look at the difference between, in a one sample t-test, we look at the difference between our mean and the hypothetical population mean, right? And we divide that by the standard error of the mean. In this case, we simply look at the mean difference between those two groups, and we divide it by something called the standard error of the difference. Okay, now this is something different that we haven't dealt with yet. Right? So let's talk a little bit about that standard error of the difference. You're still looking at how far away these two things are divided by some standard error. So remember, on like a normal distribution or a t-distribution in this case, right? And in this case, we have 3,000 plus sample size. So really, we're looking at basically a normal distribution, right? In a normal distribution, you have a distance between 2 points and divide that by the standard error. You see how far away they are apart. The distance between them, that distance, if it's far away, then it's unlikely to be 0. Does that make sense? So the more standard errors you are away, the less likely it is that the difference is 0 in the population. Okay? So that's what we're testing. So let's talk about that standard error of the difference, because it's not the same thing as the standard error of the mean. All right? So to calculate that, there's actually 2 ways to do it. I'm going to go into some depth on one of the ways in a moment, but I'm going to show you the easy way, which is really the preferable way in most cases. And this is what it looks like. You'll see this is way simpler than what's in your textbook. Okay, so it's just the square root of the sum of the square of both standard errors of the mean. Right? So you have the standard error of the mean 0.573 for those without college degree and 0.76 for those with college degree. That's it. It's different than the one in your textbook, though. That's a little bit hairier. Mathematically, they are very similar. Often, in fact, usually they're identical. Here's what the one in your textbook looks like. It's a lot different, right? It's a lot tougher, right? So there you can see that N1 would be the sample size for those without college degrees. S1 is the standard deviation, right? Same thing with N2 and S2, okay? Now, mathematically, they're very similar, often identical, okay? And we'll talk a little bit about those differences in a moment. Okay, but we're going to work with this one. This is going to be the one I'm going to ask you to use from here on out, mainly because it's considerably simpler, and in most cases, they're the same thing. Or functionally the same thing, at least. All right, so to calculate our standard error of the difference here, we plug in our 2 standard errors of the mean, which are right there. We simplify it, and we get a standard error of the difference equal to 0.952. So that's what goes in the denominator of our t-test calculation. Okay, so let's do that. So it's just x1 minus x2, the mean of x1, minus the mean of x2 divided by the standard error of the difference. So here we have x1 is those without college degrees. All right, so there's that divided by the standard error of the difference that we calculated on the last slide. And here's what we get. That's our t value. Okay, so t is negative 7.96. Now you're probably hopefully getting a little used to seeing t-scores and what you expect to see if something's significant. All right, this is a really high in magnitude. Of course, it's negative, right? But the magnitude of it is very high at 7. Now, remember, when we're using a t distribution, we need to use the number of degrees of freedom. Now, again, I'm not going to worry about walking you through everything here, but remember, we use standard error of the mean. We used 1 degree of freedom in a 1 sample t-test. Okay, what about in this test, in a 2 sample t-test? Well, think about it. We use the standard error of the mean twice. So the degrees of freedom is the combined sample size minus 2. Okay, because that's the number of things that could vary. And again, you could just memorize this, and I'm fine with that too. All right, but that's how you calculate the number of degrees of freedom. So here we have 2,429 plus 1,142 minus 3,569. So our t, and again in parentheses beneath that t, is our degrees of freedom, is equal to negative 7.96. Okay? So now we determine the critical values. So what do? We consult our t-table. We have over 100 degrees of freedom. We have 3,500 something degrees of freedom. For a 2-tailed p-value of 0.05 with 100 degrees of freedom, according to table B2 in your appendix, we need a t of at least 1.984. Ours is negative 7.96. The magnitude of our t is greater than the critical value. And of course, the actual number is less than, but really, right, negative, positive, doesn't matter. As long as the magnitude is greater than 1.984, our t is greater than that, exceeds the critical value. Since our t, at least the magnitude of it, is greater than the critical value required for p is less than or equal to 0.05, we can reject the null. P is, in fact, less than 0.000001. So we can reject the null that the two means are the same. We have found additional support that education is associated with more favorable attitudes towards transgender people. All right, now I want to talk to you a moment about this disaster. Okay, now when you run these things in SPSS and you do that in your textbook and you run that example in your textbook, or you do it for the lab that we're going to do this week, all right, one of the things you'll note is that SPSS gives you two versions of a t-value. The first one it assumes that the variances between the two samples is not equal. If the variances are not equal, this is what you would use. Okay? So what you can actually do, and I'll work through this when we look at our results in our lab this week, right? What you'll see is that first row, it actually provides a test called Levene's test for equality of variance. You'll see whether or not those two variances are equal. If that test is not significant, then the variances are equal. You can use the second row. In this case, right, even though the first calculation with this yields a different standard error of the difference, the variances are not statistically distinguishable. So as a result, we can use that simpler version. Okay, so again, looking at your SPSS output, right, you're going to get a standard error of the difference of that on the second row of your results, which is going to give you the p-value that we calculate, or the t-value that we calculated. All right. If you use the other version, which is in the first row of the SPSS output, you'll get something very slightly different. Okay. But again, 99% of the cases here, you're going to end up where the variances are not statistically distinguishable. So this is the test you could use. This is the calculation you could use to calculate the standard error of the difference. All right, so just again, very quickly, we have found additional support that education is associated with more favorable attitudes towards transgender people. Okay, voila, that's it. Let me know if you have any questions. Of course, I'm always available via email. I'm always available in my office hours, which I post at the end of all of these videos after my little inspirational quote, which hopefully helps give you a little bit of life. Okay? Reach out. Let me know if you have any questions. Hope you all do very well today.